Hello everyone. In today's video, we're going to cover rational and irrational numbers. Our learning targets for today are I can explain the meaning of rational and irrational numbers, and I can classify real numbers as rational or irrational. Let's talk a little bit about rational and irrational numbers. So a rational number is a number that can be written as a fraction or a decimal. Rationals include terminating and repeating decimals. Terminating meaning ending, and repeating meaning same pattern over and over again. And rational numbers include perfect squares. Irrational numbers cannot be written in fraction form. Irrational numbers include non-terminating and non-repeating decimals. They also include non-perfect squares. Let's look at a few numbers and determine if they're rational or irrational. So -12 is a rational number because it can be written as a fraction. Pi is irrational. It never ends and it does not repeat. 0.6 is rational. It's a terminating decimal. 7/8 is rational. Can be written as a fraction. 0.12345 is irrational. Those three dots means that it will never end. 0.33 repeating is a rational number because it's a repeating decimal. The square root of 20 is irrational. It's a non-perfect square. -1.75 is rational. It's a terminating decimal. And the square root of -121 is also rational because it's a perfect square. Now looking at some sample problems, we have problem 1. Joseph wants to find the side length of a square that has an area of 150 feet. Should his answer be rational or irrational? Why? So remember, area of a square is side squared. So if I'm given the area of my square to be 150 feet, that means both sides multiplied together will give me 150. So in order to find one side length, I'll take the square root of both sides. So one side length is the square root of 150 feet. So since my side length is not a perfect square, this number would be irrational. Number 2, which value from the following list of numbers is not a rational number? So remember, a rational number is a number that will terminate or repeat. An irrational number is a number that does not terminate or repeat. So looking at my set of numbers, the only number that will not repeat is the square root of 30 because that is a non-perfect square and non-perfect squares go on forever. Number 3, Brad converted 5/11ths to a decimal and his result was a repeating decimal. Does this mean that the value is rational or irrational? Explain your answer. Every repeating decimal is a rational number. Therefore, 5/11ths would be a rational number. Also, since you can write 5/11ths as a fraction, that makes it rational as well. Number 4, state whether the given values are rational or irrational. A, 3.4567. This is a decimal that ends, therefore it's a rational number. B, 3.4567 ... Those three dots tells me that this number goes on forever and it does not have a repeating pattern, therefore this number would be irrational. C, 3.4567 with a repeating bar over the 7. This number is a repeating decimal, therefore it would be a rational number. State whether the given values are rational or irrational. 6 plus the square root of 30. The square root of 30 is an irrational number. If I add a rational number to an irrational number, it's still going to be an irrational number. So A is irrational. B, the square root of 6 plus 30 inside my radical. So if numbers are inside my radical, I can add them together. So the square root of 6 plus 30 would be the square root of 36. And we know the square root of 36 is a perfect square, so that number would be rational. And C, I have the square root of 6 plus the square root of 30. So two non-perfect squares added together, which are both irrational numbers. If I add two irrational numbers together, I'm still going to get an irrational number. And 6, give an example of an irrational number that is greater than 10. There is an infinite amount of numbers that you could have. An irrational number that is greater than 10 could be any non-perfect square that's bigger than the square root of 100. So we could say the square root of 101. In this lesson, we learned that rational numbers are numbers that can be written as fractions or decimals. They include terminating and repeating decimals and square roots of perfect squares. Irrational numbers cannot be written in fraction form. They include non terminating and non repeating decimals and square roots of non perfect squares. That's a wrap on this video. We'll see you in the next one.